So today's lecture, so we'll see what are the applications of nanotechnology. So we have seen so many, we have seen what is nanotechnology, what is nanoscience, right? So what are the different methods of fabrication of materials, nanomaterials. So what are the ways in which the materials can be fabricated? And we have seen certain characterization materials. So materials fabrication can be done for has gone for characterization, and those characterization we have seen certain characterizations like X-ray diffraction technique, neutron diffraction technique, scanning electron microscopy, transmission electron microscopy, magnetic force microscopy, atomic force microscopy, scanning probe microscopy. So these are all what characterization techniques that we have seen in our previous lectures. And in today's lecture, we shall see what are the main applications of nanotechnology. So what are the applications, right? So from applications of nanotechnology. So nanotechnology, we shall see some of the introduction factors of nanotechnology in India, as I told you. So IIT Mumbai is a premier organization in the field of nanotechnology. Research in the field of health, environment, medicines are still on. Starting in 2001, the Government of India launched the Nanoscience and Technology Initiative, NSTI, right? So then in 2007, the Nanoscience and Technology Mission 2007 was initiated with an allocation of rupees 1,000 crores for a period of 5 years, right? So 2007, the Nanoscience and Technology Mission 2007 was initiated with an allocation of rupees 1,000 crores for a period of 5 years. So that is what the Government of India has given. For the development of nanoscience or nanotechnology mission. Okay? So Nano Mission, that is what to Nano Mission 2007. So the main basic objectives of the Nano Mission are, so it is a basic research promotion, infrastructure development for carrying and front-ranking research, and development of nanotechnologies and their applications, human resource developments, and international collaborations. So these are some of the main objectives of Nano Mission. Nano Mission main objectives: basic research promotion, promotion of research, promoting the research in different areas, and incorporating with the nano, right? And infrastructure development for carrying out the front-making research, infrastructure like establishing the research labs and clean rooms, and development of nanotechnologies and their applications, and human resource development and international collaboration. So these are some of the nanotechnology where in India where Nano Mission has granted some thousands of crores of rupees for the development of Nano Mission. So if you come to some of the fundamentals of applications, we have nanotechnology in mobiles, right? Morpho, a nanotechnology concept device developed by Nokia Research Center, NRC, at the University of Cambridge. The Morph will be a super hydrophobic, making it extremely drit repellent, right? So where the nanotechnology is also incorporated in electronics, electrodes made from nanowires enable flat panel displays to the flexible as well as thinner than current flat panel displays, right? So LEDs, LCDs like this is what we can see. We have the nanolithography is used as a fabrication of chips, nanolithography. So the transistors are made of nanowires that are that assemble in the glass thin film or flexible plastics. So e-paper displays on sunglasses and map car windshield. The Morph will be a super hydrophobic, making extremely drit repellent. It will be able to charge itself from available light source using photovoltaic nano white glass covering its surface. Nanoscale electronics also allows stretching. Nokia envisages that a nanoscale mesh of fibers will allow mobile devices to be bent, stretched, and folded into any number of conceivable shapes. Right? So nanotechnology in computers. The silicon transistor in our computer may be replaced by transistor based on carbon nanotubes. So we have the silicon enabled chips, that is for very large scale integrated chips based on VLSI design, that is fabricated. The substrate materials that people use are silicon transistors, silicon materials. So the silicon transistor in our computer may be replaced by transistors based on carbon nanotubes. A carbon nanotube is a molecule in the form of hollow cylinder with a diameter of around a nanometer, which consists of pure carbon. Nanorods is an upcoming technology in the displays technique due to less consumption of electricity and less heat emission. Size of the microprocessors are reduced to greater extent Research at North Carolina State University says that growing arrays of magnetic nanoparticles called nanodots, So nanodots, that is what arrays of magnetic nanoparticles, where the research was encountered at North Carolina State University, right, in Carolina State University, right. So this is what the nanotechnology, how it has been incorporated in computers. So silicon transistors have been replaced by carbon nanotubes. Right, we know that a carbon nanotube is a molecule in the form of hollow cylinder with a diameter of around 1 nanometer, which consists of pure carbon. And we have nanorods in coming technology in place of displays. So techniques due to less consumption of electricity and less heat emission. The size of microprocessors are reduced to greater extent. Right. So, and another research is going at North Korea State University says that the growing arrays of magnetic nanoparticles called nanodots, right. So, Hewitt Packard developing a memory device that uses nanowires coated with some titanium dioxide. One group of these nanowires is deposited parallel to another group. When a perpendicular nanowire is laid over a group of parallel wires at each intersection, device called memory star is formed. A memory star can be used as a single component memory cell in an integrated circuit. By reducing the diameter of the nanowires, researchers believe memory chips can achieve higher memory density than flash memory chips. Magnetic nanowires made of alloy of iron and nickel are being used to create dense memory devices. Chips are designed, developed, produced by Intel before I-series processors were between 65 nanometers to 45 nanometers. Later, with the help of nanotechnology, 220 22 nanometer chips were fabricated, which itself is a milestone. So what are the advantages of using carbon nanotubes? So faster and smaller. Carbon nanotubes can be used to produce smaller and faster components. This will also result in computers that consume less energy. High speed and high capacity memory allow circuits to be more accurate at the atomic level. So possibilities for the future, nanotechnology make it possible to feature lighter, stronger and programmable materials that requires less energy to produce that conventional materials. And that promise greater fuel efficiency in land transportation, ships, aircraft and space vehicles. The future of nanotechnology could very well include the use of nanorobotics. These nanorobotics have the potential to make on humans tasks as well as tasks that humans could never complete. The rebuilding of this depleted ozone layer could potentially be able to be performed. So these are the possibilities for the future in nanotechnology. So what are the pitfalls of nanotechnology? Nanoparticles can get into body through the skin, lungs and digestive system, thus creating free radicals that can cause cell damage. Once nanoparticles are in the bloodstream, they will be able to cross the blood-brain barrier. The most dangerous nano application used for military purposes is the nano bomb that contain engineered self-multiplying deadly viruses that can continue to wipe out a community, country or even a civilization. Nanobots, because of their replicating behavior, can be big threat for grey goo. So these are the potential impacts of nanotechnology. The materials are still resonant cloths, so healthcare, chemical and biological sensor, drugs and delivery devices. Technology, better data storage and head of computation, environment, clean energy air. Thin layers of gold are used to be in tiny medical devices. Carbon nanotubes can be used for hydrogen fuel storage. Possible entry point for nanomedical devices. So these are what some of the applications, potential impacts of nanotechnology. Materials paint that doesn't chip. So protective nano paint for cars, water and dirt repellent, resistance to chipping and scratches. So brighter colors, enhanced gloss. In the future, could change color and self-repair. So these are Mercedes covered with a tougher, shiner nano paint. So environmental nano solar cells. Nano solar cells mixed in plastic could be painted on buses, roofs, clothing. Solar becomes a cheap energy alternative, right? So this becomes a cheap energy alternative. We have the nanorods, electrodes, and we have the glass. And sunlight is allowed to fall on the glass, electrodes, and we have the electrodes, nano solar cell, an organic membrane in semiconducting polymer sandwiching between the two electrodes. So we have technology building smaller devices and chips, nanolithography to create tiny patterns, patterning on the substrate like silicon, writing on patterning. So lay down ink by atom. So transporting molecules to surface by dip and nanolithography. So this is what the Mona Lisa, which was written by using nanolithography. Mona Lisa figure is being written on a chip created by EF and nanolithography. So healthcare nerve tissue talking to computers, neuroelectronic networks interface nerve cells with semiconductors. Possible applications in brain research, neurocomputation, prosthetics, and biosensors. And healthcare detecting devices, quantum dots glow in ultraviolet light injected in mice, collect in tumors, could locate as few as 10 to 100 cancer cells. So quantum dots, we have nanometer sized crystals that can free electrons and emit photons when emitted to ultraviolet. Early tumor detection studied in mice. So healthcare, growing tissues to repair hearts, nanofibers helped creating muscle grow in the lab. Filaments instruct muscle to grow in orderly way. Before that, fibers glue in random growth. Healthcare, preventing viruses from infecting us. Nanocoatings or protein on viruses could stop viruses from building to cells. Never get another cold or flu. Never getting another cold or flu. So, preventing viruses from infecting us. So this is gold tethered to the protein shell of virus, right? So healthcare, making repairs to the body. Nano robots are imaginary, but nano-sized delivery systems could break apart kidney stones, clear plague from blood vessels, ferret drugs to tumor cells. Right. So we have some tumors. We have some certain body parts. We have pumps that remove from the body and dispersive drugs. Right. So nano devices are sensitive. Radiation particles can cause fatal defects. Radio defect can cause fatal defects. Right. Development requires very clean environments. Very clean environments. Redundant copies compensate for high defect rate. So summary, nanoscience at the nanoscale, an emerging interdisciplinary research integrates chemistry, physics, biology, material science, engineering, exercise, and computer science. The power to collect data and manipulate particles at such a tiny scale will lead to new areas of research and technology design, better understanding of matter and interaction, new ways to tackle important problems in healthcare, energy, the environment, and technology. A few practical applications now, most are years or decades away. So these are the references where we have taken some of the applications. So overall, these are some of the applications where people will use, where people use this type of technology for their user, for their devices, for their user, for user friendly, right? So technology is very much user friendly if you observe the particular stream in nanoscience. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.